All right, everybody. So let's go into a couple of questions that I wanted to focus in on from the final exam study guide that I think will be particularly helpful when you're going through your studies for the final exam that's coming up in a couple of weeks. I have this organized based off of questions that we're going to be looking into from Module 4 onward, so 4 through 7, and then I have them organized from how the study guide has it organized. So you can follow along with the one that's attached onto the Canvas page. But without further ado, let's get started with a couple of the problems that I want to focus on for today's review. So the first problem comes from Module 4. It's question 1A. And the question is asking, what is the critical z-value you use to create the following confidence interval? And you're given the confidence interval of 90%. In other words, this value is going to be like your c-value, okay? Your confidence level. And this is a straight, are you able to review it? Are you able to pull it from the text, like from the formula book and understand what it's even asking you, okay? So here you have 90%. This is the same as 0.90. So then you go into this part where this part of the formula book that says areas of standard normal distribution, and you look at the part that says like confidence interval critical values, and you correspond the level of confidence to the critical value. So here, 90%, I find the part that says 90, which is right here, and we see that that answer is 1.645. This is your critical z-value. Okay, very super easy. If you see a problem similar to this on the final, definitely don't want to skip this one. Go straight into the formula book and see what you could do from there. That's my biggest piece of advice for any of these problems. If you don't know what to do, one of the first things that you can do is just look at the formula book and see what things you can correlate with variables that you know. What do you know from the problem, and then work backwards in that way. So this is given to you on your formula book, and it will be a part of your final exam. So make sure that you're using everything to its fullest, because it might simply be there and you don't even have to do much to calculate, really. We saw this is pretty straightforward. Okay. Next problem. Assuming all else is equal, what is the key impact confidence intervals have on the width of a width of a confidence interval? The confidence level has on the width. I'm sorry. Okay, so this is question 2 from your guide here. So here we see that the confidence level is directly proportional to the width of the confidence interval. That's like the main takeaway that we have here. In other words, as the confidence interval increases, the width of the confidence interval also increases. The critical z-value gets larger, which increases the margin of error. So one of the ways that you can help remember this is by looking at your formula sheet again, and you look at the part that asks you about like confidence intervals. You can look at the population or the proportion one for this one, because it didn't really specify what we were talking about, but either way, the trend is the same. So if we recall again, we have our point estimate as the first term in our expression, and then the second term of the expression, this is going to be our margin of error. Okay, so this problem, error, is specifically talking about this part that I'm going to emphasize here in pink. Okay, because the margin of error is sort of giving us that wiggle room when we're building this confidence interval, and it makes the confidence interval wider or smaller. Okay, and to help with this problem, what we would do is look at the different variables that are included in this margin of error. So we have the critical value, we have the standard deviation, and we're dividing it by the sample size. Okay. Now we also know that when we're talking about confidence level, we're talking about C. Okay. So in particular, when we're looking at the margin of error and we're looking at the confidence interval, the part that's going to be impacted the most is going to be this critical z value. And You could, you might be able to know the relationship right off the top of your head. If not, you're able to use this wonderful chart that we have in our formula book as well. And you could start looking at how the critical values change given the changes in the level of confidence. So as we see, as the confidence interval increases from like 70 to 98, right, we see that the critical z value changes from 101.04 to 2.33. We see that the level of confidence was from smaller to larger. The critical value goes from smaller to larger as well. So this is like visually how we can see this like through like a chart, basically. Another way that you could think about it is through our friend the standard distribution curve. So let's say that we have two standard deviations and we have two critical values attached to them. So we have 90 or 0.9 and I'm going to make it more dramatic. We're going to do 80. That's not really like a one that you'll see a lot, but and 95. So if we remember, when we're talking about like these confidence levels, we want to think about it as the area underneath the curve that is confined by the boundaries of our confidence interval. So, and it's symmetric about the mean in this case. Okay. So basically when we're talking about a confidence level, we're saying that 80% is going to be within these two boundaries. Let's say that the boundary is like negative ZC. Well, actually, I could just leave it as ZC and positive ZC. Meanwhile, when we have 95%, we're going to be spread out more because we're having a larger area underneath the curve here. And just to be a little clear with this diagram, I'm going to write in the confidence intervals underneath, the confidence levels underneath as well. Okay. So 95% for both of these, not 90. And we start to see this little visual going on between the two different types of confidence levels. Another way that you can think about it is just more intuitive. If you want to be more certain about something, you want to include you want to include more and more possibilities. So you're being less specific, but you're being quote unquote the chances of you being more accurate is higher. So that's like a overall application of it too. Okay. But either way you think about it, it'll get you to the same thing, where it's directly proportional to the width of the confidence interval, meaning if the confidence level increases, the width also increases. Okay. Number 3, which of the following impact the margin of error of a confidence interval about the mean? And here we have a couple of things that are listed. And here, again, it's just a reminder that if you're using like the equations from your formula book, that the margin of error is the part that is added or subtracted. So it's that second term in our equation. So again, we're zooming in on that second term here, okay? And we want to consider the variables that are here. So automatically we see that the sample mean isn't included in this term that's circled, right? We see that the sample mean is like included on the outside, but that's our point estimate, and that's not talking about the margin of error. So that's one way that they might trick you on that part. That even though it is influential to the confidence interval and where that confidence interval is going to lie on a number line, it doesn't directly impact the margin of error, okay? This is the same for median and mode. It's not a part of the formula in general, so those are a little bit easier to determine. We want to think about what's included and what's not included, basically, when we're talking about like if it's impacting the margin of error. And the other three are impacting by it. We see the sample size is affected, which is going to be in the denominator here. We know that n stands for sample size. And basically, one way to think about it is that it's inversely proportional. So as the sample size increases, the denominator of the fraction increases. And that makes this fraction smaller, which makes the margin of error smaller in itself. So in other words, like if we're thinking about just the idea of like the sample size increasing, we're thinking about this denominator getting bigger. So let's say we're comparing a sample size of 5 versus a sample size of 20. We can easily see that 1/5 is greater than 1/20, okay? But the sample size itself increased as we went from left to right. And that's what we mean by making the fraction smaller when we're looking at this relationship. And when we're multiplying by a number that's smaller, in terms of being a decimal between 0 and 1, that's going to make that whole term smaller in itself. And because of this, that's going to make the margin of error decrease. And even taking a step back, if we're not looking at the equation in itself, this intuitively makes sense too. If you have more and more individuals in your sample, you're getting closer and closer, relatively, to the whole population being included in your study. So having a larger sample inherently makes it more representative and applicable to other individuals as opposed to a smaller group. I guess you could think about it in that way as well. I'd rather trust, like, if we want to try like looking at it more of like an applicable way, trusting a study that has 20 people versus trusting a study that has 20,000 people. The one with 20,000 people might have more insights that are applicable to a whole bunch, like to the rest of the population more than just the one that was 20 people. So it relates to the power of the study as well. Okay, so sample size is pretty high yield for the exam, so I really wanted to dive deep into that. But let's briefly go over the confidence intervals as well. So we sort of talked about this in our previous question, the confidence level. As this confidence level increases, the critical value increases. We're multiplying by a bigger number in this term. It's not in the denominator, so we don't have to think about it as anything crazy. A bigger number, like if we were to talk about like 2 times 5 versus 2 times 20, obviously when we're multiplying by 20, it's going to be, we're going to get a bigger number, even though that first one was the same. Okay, so confidence level increasing, that Z critical value also increases as well, increasing everything on that second term. And finally, we have our standard deviation. Okay, and it is affected. It's included in the numerator of the fraction in the margin of error equation. So here, because it's in the numerator, it's sort of like based off of PEMDAS. You could also think about it as like multiplying the critical Z value by the standard deviation and then dividing by the sample size. So in that way, we could think about it as we're multiplying that whole number by standard deviation in itself. And if that number gets bigger, we see a direct relationship with that margin of error where it also increases as well. So the only one that has like a different kind of like relationship with it in terms of it being inversely proportional is sample size. Whereas with confidence interval and standard deviation, you're looking more at like a directly proportional, where one increases, the other does as well.